In this lesson, we're going to talk about lists and what exactly they are and how to work with them and how to manipulate them. We're also going to talk about how lists are mutable. What does that mean? And compare that to our immutable data types that we've been talking about, such as a string and a tuple. So let's get started with these kind of fun, everyday use data container called the list. So what exactly is a list? Well, a list is a sequence. It's just like a string or a tuple, but it's created using the square brackets and commas instead of the parentheses and commas. And lists are mutable. That means that place order and values can be changed on the fly, and without having to reassign that variable that's in there. So let's take a step back and tell you kind of exactly what does that mean. So when something is immutable, that means that the taking even a step back further, when we look at computers and we're writing programs, everything is written in works inside of the RAM, right? Until we actually save it into like a file or read it from a file. It all gets thrown into the RAM. So when you create a variable, it actually gets placed into RAM. For a tuple and a string and some of all the other immutable data types, once you allocate that space inside of that RAM, the contents of that RAM will never change for the duration of that execution of that program. Asterisk up there, kind of, but essentially when you assign a variable to that, you can't change the contents of that RAM. In order to change a variable that has a mutable type, a immutable type, you have to then reallocate a new section in RAM, put in the contents of your data inside of that RAM, and then point that variable to that section inside of the RAM. An immutable or a mutable container, once you allocate that RAM, the contents that's inside of there can be changed. You can alter them. You can play around with them. You can swap them around and move them. So that's really the biggest difference between immutable and mutable data types. Let's really kind of deep dive and get into that. So under module 5, we're going to create a new file, and let's call this one intro lists.py. Okay. If dunder name is equal to dunder main, just like that. Now, let's create a list. So remember, we create a list using brackets and commas. So let's pick out some just of our primary colors here. Red, yellow, blue, and let's do green in there. Now I know, but I wanted to have a few more than just the primary 3. So let's print out what our colors looks like, and let's print out the type of our colors. We're going to do Python and do intro lists, and ta-da, we have red, yellow, blue, green, and its class is list. So there you go. Now you know how to create a list. What does that really mean though? Well, let's play around with it. But here's another way we can actually create a list. Let's do the hello list. So just like we did in with a tuple, we can do list, so wrap it around there, and then put in hello there. Print hello list. And ta-da, there we go. So this list, just like the tuple, it takes any type of data container and converts it over to a list. That means that we could also do a tuple. So my tuple is equal to 1, 2, and 3. We're going to print my tuple. And then we're going to do my list is equal to list of my tuple. And then print out my list. Like that. I'm going to comment these guys out here. Rerun this script. And we can see we have a tuple. And out of that tuple, we've created a list. So very similar to tuples, we can iterate over them. Using our for loops. And here we have each one executed there. And then we can also make changes to our list. So let's go to this. Let's comment this out. And let's play around with our colors list like this. So let's say, you know what? I really don't like the name red. I want to change that to cayenne. So colors, very first index, that's going to be equal to cayenne, like this. Now, when we did this with tuples, we weren't allowed to do that, right? That didn't work. But with mutable objects, such as a list, we are. So let's run this and see what happens. Red, yellow, blue, green, and now cayenne, yellow, blue, green. We've made changes in there. And that's awesome. That's exactly what we want to do. That's where lists are really kind of interesting. They're awesome. We can also sort them. Sort them? What does that mean? Well, we can do colors.sort and then print our colors like this. So we had red, yellow, blue, green, cayenne, yellow, blue, green, and now blue, cayenne, green, yellow. So how is this sorting? Well, it's sorting by the value of the strings that are inside of there. And so when we say the value of that string, there's an interesting thing. If I drop into an IPython's shell and I do ord of a character, any character in there, I get a value in there. That's that Unicode or ASCII encoding that we were talking about in there. Everything that we deal with always has a numerical value to it. It always translates into those ones and zeros. So when it's sorting through this, what it's doing is it's actually checking to see what the different ord values of each of these characters and starts sorting it based off of that's in there. Okay, so that is how you sort a list. Now we've got strings inside of here. We could easily replace them with numbers and it'll sort them by the numbers that's in there. I don't know if you can sort with mixed. So let's see what happens. So my list is equal to 1, and then 1, and then 2, and then 2. And then my list dot sort. Let's see if this works. Where did we have the error? In our intro lists.py on line 27 again. Wow, that's interesting. Right there, we see the contents type error. Less than, not supported between instances of stir and int. So that means it's doing a comparison there if it's less than or greater than, and then it starts sorting them that way. So we can't do mixtures of certain types and sort them. That's in there. You're going to get an error that way. So, you know what's another thing that we could do? I've decided that, you know what? I actually do want red in there, but I want to keep cayenne in there. So I'm going to do colors.append red. So what this does is this actually appends the value to the end of this list. So let's print out our colors here. So red, yellow, blue, green, cayenne, yellow, blue, green. Now it's blue, cayenne, green, yellow, and then red. We've thrown that in there. So we've thrown that in there. So not only have we sorted it, but now we've added another element into there. Here's another interesting application for this. Whoops. Let's say I want to do some calculations to a list or calculations to some values. But I don't necessarily know, kind of what's going on with those values, or I want to iterate over a range. So let's just say numbers is equal to an empty list. So here's an empty list, nothing inside of it, just open close brackets. That's how you create an empty list. For I in range 5, so 0 to 4, I'm going to do numbers dot append. Let's do I squared. So let's take the square of each of those numbers. And then let's print numbers and see what that looks like. 0, 1, 4, 9, and 16. Oh, awesome. That's perfect. That's exactly what we wanted to do. So just as we can append to a list or add to the end of it, we can also pop from a list. That means remove the last element in there. So num is equal to numbers dot pop in there. So what this is going to do is this is actually going to take the last number, remove it from there, and print it and add it to, assign it to the num variable. For this one, I want to debug and really show you what's going on here. So over here, we can see our numbers is an empty list. Okay. We have I, which has a value of 0. We take I squared and append it to that. So now our first element in there is 0. Now we do this again, and now it's 1. You notice that the length is changing because we're adding new elements to this list. And it's being filled up. So now that we're done, we have 0, 1, 4, 9, and 16. So now we're going to print out our numbers, and now what we're going to do is we're going to pop. So now num is 16 over here, and look at our numbers, and look at our length. Before it was 5, now it's 4. The last element in there was 16, and now it's 9. Now we can print those out, and we can see 16 is in there, and we removed that 16 that's in there. You don't have to assign that number. Let's just say you want to pop the end of a list for whatever reason. Just remove whatever's at the end of that list. You can do that. Let's rerun this. Let's run this. So here's another interesting lesson. I keep cding into or changing directory into the module 5. What I'm going to do actually is do Python module 5 /intro lists. So you don't have to be in the directory that you want to execute your Python file. You can actually give it a path to there, and it'll go in and execute this. So we're going to go ahead and run this, and look, num is not defined because we were trying to print it. Let's do this one more time. And look, 0, 1, 4, 9, and 16, and then 0, 1, 4, and 9. There we go. Okay. So we've learned how to append. We've learned how to pop. We can also do something interesting with these. We can combine lists. Let's look at that. So first is equal to list of range 5. And then second is equal to list of range, let's do 5 to 11. Actually, you know what? Let's do 10. So we'll get 0 through 9, 10 items. Then combined is equal to first plus second. So this is that operator. This is that addition operator. Because the addition here is you're adding or combining those two lists together. So let's print first, then print second, and then print finally our combined in there. We're going to, whoops, run our script. Here's 1, 0, 1 through 0 through 4, 5 through 9, and now we have 0 through 9 by combining them in there. So the addition operator, when you use them between two lists, combines the lists together that's in there. We can also index into our lists. Let's comment this out. And let's index in this. So let's print our combined list, but let's only look at elements 2 through 7 in there. And remember, our indexing is start is included, and the ending is where we stop, but not included. So we run this, and 2 through 6 is what we got. So we can do that. And so that's the same way. We can grab a single element out of there, like this. And that's 5. It's in there. So you can index out of those numbers. Lists also have a length to them. And you can do that by doing len. But here's another one that's really interesting. You can also find the max of something. Now you can technically do this with a tuple as well. But so if we print out the max value of something, we can see that, let's get rid of this. The max value in there is 9. Cool. We can also take and find the min. And finally, we can do the sum of something. So let's rerun this. 9 is our max, 0 is our min, and 45 is our sum of all of the elements that are in there. This sum is the equivalent to something like this. Total is equal to 0 for I in combined I plus equals, total plus equals I, like that. And then print total. There we go. So this sum is the equivalent of this for loop combination right there. So let's talk about and mess around with oh, you know what? Let's actually play around with some strings here. Now let's play around with strings and what we can do with them. So I'm going to comment this out some more. And let's do this. So Pokemon is equal to Pikachu comma Bulbasaur comma Charmander. Like this. My Pokemon is equal to Pokemon dot split. And our delimiter is going to be this. So what this does is this is another string method called split. It's going to split up this string into a list. And it's going to split it up by taking every time it sees this delimiter that we pass into it. So this comma here is going to remove the comma and then add what is in between each of the commas into a list. So let's print my Pokemon. We got an error here, an indentation error, because we've unindented too many. That actually should be just fine. What are we missing here? Oh, because there's nothing else inside of there. Okay, so now let's run this. And we can see Pikachu, Bulbasaur, and Charmander are in there. We're all split up from that. And that's pretty awesome, I would say. Finally, we can check to see if something is inside of a list. So let's print if Bulbasaur in my Pokemon. And run our file. There we go. Cool. So that's pretty neat. Now, here's one last thing that I want to talk to you about, and that's copying lists into something. So here we've got our Pokemon here, right? So my Pokemon, which should be, you know what, I'm going to make this, well, yeah, let's just leave this. So my Pokemon, we have it printed out here. We see what this looks like. Let's say I want to, so I've got my Pokemon here. Let's say my Pokemon represents my party, right? But I want to do a Pokedex, right? I want to create a Pokedex and start working on that. So what I'm going to do is I'm going to say my Pokedex is equal to my Pokemon, right? Because I've already caught these Pokemon, and now that I've got my Pokedex, I know that the Pokemon that I've already caught needs to go inside of my Pokedex, right? So we're just going to start over and just start with that, right? Okay, cool. So now as I travel along and I'm going and I'm fighting, I come across the ever elusive Mew, right? Oh, great. So here, let's do this. Let's print my Pokedex. And let's print my Pokemon in there. Cool. All right. So now I come across Mew, and oh man, I didn't get to catch him. Very elusive, but I at least got to see him. I took a small little picture of him. So I'm going to add to my Pokedex Mew. Obviously, I don't want to add it to my Pokemon because, well, my Pokemon, I didn't catch it. So let's print this out and make sure that this worked the way that we wanted. We're going to debug this, run this in our debugger. And here we go. So starting off, my Pokemon, these are what I've caught. I've got a Pikachu, a Bulbasaur, and a Charmander. And now Pokedex over here. So we can see Pokemon and Pokedex. Hey, look, they're both the same values in there. Cool. It copied it the way that we wanted it to. All right, so now we're going to append Mew to it. Okay, so we look over here at Pokedex. Mew is added right here. All right, perfect. That works the way we want. So we're going to print this out, Pokedex, and now print my Pokemon. And wait a minute. That's not what I expected it to be. Both Pokedex and my Pokemon? What's going on here? What is this? Let's rerun this again. I believe we messed this up. Let's see what happens. I don't know why there's a debug point there. Here we go. Okay, so let's do, instead of this watch, let's add this ID of my Pokemon, and then ID of Pokedex. Now, that's interesting. Identifies where in memory, it's like a memory address, where in memory that variable lives. And so I've copied, I said, hey, Pokedex is equal to my Pokemon. But what it's done is it's given me the exact same location in memory. That's not what I wanted. So what's happened here is I've actually just passed a reference to this very same list. So that's kind of what happens when you start messing around with mutable objects and you do assignment operator, then, well, that's not going to work the way that you want it to necessarily. And so you're going to be, instead of copying over a list, you're actually copying over a reference to that list. So if we want to copy the list, then you're going to do this. And what that does is you're basically slicing the entire list. So because there is no start and there is no end, it's assumed to be the very beginning and the very end that's there. So now let's run our script. And now we can see, hey, Mew is added to Pokedex, but not added to my Pokemon. And so there we go. That is a brief overview of lists and how to work with lists and how to work with them and some of the differences there. The big thing to take away is that mutable objects can be changed, whereas immutable objects can't be changed. And one good thing about mutable objects is you can pass them around and work with them throughout different variables, but you have to be careful. So if you actually want to copy a list, remember to use this syntax instead of doing just a straight up this equals that. So next up, we're going to talk about dictionaries and how to work with those.